Okay, so there's just a question about what chapters we're doing each week, which is a good question. I don't see where I was as clear, except for the first week, on what chapters we're doing. So I will I'll update that. On the syllabus, these are the titles of the chapters that you should be reading, but I'll put the actual chapter numbers there as well. If you you click on the book here, I'll look at the HTML page. So so far we've covered this chapter 1, the way of the program, chapter 2, variables, chapter 3, functions. This chapter 4, we didn't really talk about it much. You can kind of leave that one mostly by itself. Not saying it would hurt to read it, but we didn't really cover a lot of the content. This chapter, conditionals and recursion. That's what we covered that last week, except for we did not cover recursion. We're not going to cover recursion as part of this. So we left out these 3 subsections on recursion. So anything in the book that I don't talk about, you can skip over. So now you know explicitly we're not covering recursion. Recursion is kind of a deep programming trick, but you can get by without knowing how to do it. It's a different way to create a loop. Basically, we talked about functions already. Recursion is the process of calling a function in itself. So you could like create a while loop, but instead of creating a while loop, you could just have a function that checks one of the values that's come into it, and if that hasn't been met yet, it would recall the function. So yeah, we didn't cover that part. So we did cover fruitful functions with return values. So you could read that one. We did cover iteration. We're going to cover that even more today. And today we're going to cover strings, lists, and dictionaries. We may not get all the way through dictionaries. I have that on the kind of split for this week and next week, but we'll definitely get to strings and lists, which are two cases of sequences, and we'll also cover tuples, but we may come back and cover dictionaries next week. Okay? All right, so we're almost to the end of what we're going to talk about in this course in terms of this book. So at the beginning of the class, I mentioned that we were going to spend the first 3 or 4 weeks covering just Python basics while trying to throw in some geographic elements to that. So we're mostly focusing on learning the Python language. And then after that, we won't really learn any new concepts in Python. We'll just continue to apply it to geographic problems and show you how it integrates with ArcGIS. So this is really the second to last week of just Python. We don't cover a lot of these remaining chapters. We will talk about reading files because that's something that we'll do, but we won't discuss this chapter in its entirety. We'll introduce this concept of classes and objects. But we're mostly going to be playing with classes and objects in this class, not building our own classes and objects. Anyway, that's where we've been and where we're going. And so today, make absolutely positive that I'm broadcasting. Looks like I am. So today we're going to talk about sequences. So I'm going to open up the IDLE Python window. And I did mention this last week, that a string is a sequence. A sequence is a variable that actually contains variables inside of it. In the case of a string, it's a group of characters, exactly. And so there's some cool things that we can do with most sequences. And since strings are sequences, we'll introduce the concept with strings. So if I create a variable like called name and set it equal to George, which is my name, I've created a variable that's of type string. So if I ask for the type of name, it tells me it's a string. Okay. Something's a string, therefore it's a sequence. There's some things that we can do. For example, we could loop over a string, and I demonstrated that last week, right? Where I said, we'll do that again really quickly because we'll be looping over lots of different things. So we could say name, I'm just going to repeat this, sorry. Name equals George. And then the way that we loop over any sequence is using the for keyword. For, then you think of a new variable name. And the new variable name can really be anything that you want, as long as it's not a reserved word in Python. And so this is where I said for a letter in name. And I think that that makes sense as a variable name because each time through the loop, you will get a new variable, you'll get a new value assigned to the variable letter. So the first time through the loop, the letter will be assigned the value G, capital G in fact. The second time through, it'll be assigned a lowercase e. The third time through, it'll be assigned a lowercase o. So I could say print letter. This is the example that I created last week. I'm going to go ahead and run this guy. Week 3. I'm going to call this 2016 example 1. So I run this guy through, and it does the exact same thing that it did last week. Prints my name out. Okay. So these values are ASCII characters. The computer interprets a number to mean a letter, and it prints that letter out on the screen. Okay. There are a few tricks that your books points out. One that I don't think I pointed out yet is if you put a comma after the word, the thing that you're trying to print, it will not print a new line. And so this is a cheap way to actually, not a cheap way, I guess a silly way to print the character string. Now you're putting spaces in between, but it'll print out everything on the same line. So if you ever have a loop and you want everything to print on the same line instead of printing on new lines, you can do that. So that's just a trick that the book points out. So you put in, put a comma after the thing you're trying to print, and it will keep it printed on the same line. All right, now back to what we can do with sequences. Now there are some things that you can only do with strings, and some things that apply to all sequences. The book doesn't necessarily cover them in those orders, so I'm going to start with things you can do with all sequences. And the first thing that you can do with a sequence, I'm going to go ahead and comment out this thing. besides loop through it, like I just showed you, is you can request any individual value in a sequence by referencing its place. And that place is just referenced as a number. So I could say print name, then you have to use the syntax of a bracket, the little bracket guy. Now, is that I tried to make it a little bit bigger. Is it still too small down there?
That's good.
That's good. Okay. Forgot about that till now. So we say print bracket, and then we put the number. And what I mean by the number is the index along this axis starting right here. Most of the time in computers, we start counting as 0. Okay? So the first thing is name bracket 0, and that is going to be G, capital G. So if I run this, I'm just going to get capital G as the, well, that was what was printed. See right here? Let me do this thing where there we go. So now I have them on both sides there. So print name 0. I can print name 1, run. Okay. And I got any. Now, I'm not going to necessarily demonstrate this right now, but the potential exists for example, if you wanted to logically find out if a certain file started with a certain letter, you could do that. Okay, you could do something like, so we could say if name 0 equals G, then do something. Print, your name starts with a G. So it printed out my name starts with a G. If I put in a different name and I tried to run that, it's not going to print that because Caleb doesn't start with a G. It starts with a C. All right. So we can reference these items as individual values. We can reference the items in a sequence as individual values. Now, if I said, if I tried to use something like, if I tried to print the 10th letter of that name, I could get an error. I will get an error. It's out of range. String index out of range. And when we talk about lists and tuples, which are also sequences, you'll get the same error if you try to reference them using a number that's higher than the amount of individual elements that are in there. Okay. Sorry, did you have a question? Okay. This brings us to our next topic, or our next thing that lists can do. Lists, we can, not lists, sequences, lists are sequences, we haven't talked about this yet. Sequences, we can ask them how long they are. Any sequence can be asked how long it is using a function, a built-in function in Python. And the only parameter for that function is the sequence that we're talking about. So we can always ask for the length of a sequence. So see here, I've said print the len, that's the name of the function that will return the length. And I use a parenthesis because this is a function, and I feed it that single argument. The argument is name in this case. And the name, what does the word name here represent? What is it? What is name? Well, yeah, it holds the value of George right now. It's a variable. And so I can ask for the length of any variable that is a sequence. So if I run this, the result is this is on this line right here. So it says the length of the variable named name is right now 6. It's holding a string that has 6 characters in it. So if I made this longer, now if I run this, it says that there are 19 characters. And that includes the spaces. Space here, space here. Those are all spaces. But everywhere there's 19 characters, starting at the beginning, going to the end. All right, so if I want to get the last character, I could do something like this. Name, len name. Okay, so let's walk through how this statement will be evaluated. So what is the result of this? Len, parenthesis, name, parenthesis. It's a function and it does return a result. You can either tell me specifically what it's going to return, or you can say in general what that function would do, or both. The len function.
So the length.
Yes, it returns the length. And in this case, it's going to return 19. So if we ask for the 19th element, that's actually what we usually call the items in a sequence. If we ask for the 19th element of the list in the sequence name, what will it return? You would think it would return the last element, right? But remember, we start counting at 0. So it's actually going to get an error. So we need to modify our code just a little bit so we get an error out of range. If we say -1 here, it's going to subtract that. So to get the very last item in a list, we would go like this. So now, using the function and the indexing, we can see how it's possible to gather any item in a list. I mean, any item in a sequence, any element in a sequence. We can get the first, second, third, fourth. We can get the last. Last is always -1. If we want to get the second from the last, we could do -2, and so on. Okay. All right. So let's say that this was the name of a file, which would be weird. Okay. So we have a bunch of files in a directory, and we only want to operate on the shape files because we're doing GIS. Okay. We could find out if a file name ended in .shp. Okay, right now it'd be a little bit cumbersome, right? Because we'd have to check the third to the last, the second to the last, and the very last character. And then we'd have to use an AND statement. That would be cumbersome. Well, that brings us to our next thing that we can do with strings. I mean, with sequences, of which strings are one. So far, everything we've discussed, indexing, by location, the length, and now the last thing that we're going to talk about, not the very last thing, but the next thing that we're going to talk about, the latest thing, is with a sequence, you can do what we call retrieve a slice of a sequence. A slice of a sequence is a portion of a sequence. So instead of just getting one of the elements, we can get a subset of the elements. That may be a better way to say that. So if we want to get the first 3 elements, we could go like this. I'll just keep all these examples up here. We'll put them all up. Let's say we want to print from name the first 3 elements. We would go like this. 0, colon means I want to slice it. And then we put the last element. So 0, colon, 3. That's actually going to give us, let me see what it's going to do. Yep, that's exactly what we want. So it's 0, 3, and it gives us the first 3. So one thing to keep in mind is that it's not inclusive of the last element. So it is inclusive of 0, and it goes all the way to 3 and stops. All right. So we can slice it anywhere. We could go from 4 to 8. And most of these intermediate slices aren't really that useful. Here we get GE and then the space and then the T. Okay, it's not always that useful to get the middle of a string, but every once in a while it becomes useful. For example, maybe we have a coordinate, and the coordinate is stored in a file with 2 numbers for the latitude, a space. Sorry, 2 numbers for the degrees, latitude, a space, 2 numbers for the minutes, latitude, and a space, and 2 numbers for the seconds. So if we wanted to separate those out and get the degrees, minutes, and seconds as separate numbers, we could do something like use a slice like this. Usually you want to get from the very beginning or you want to get from the very end. That's oftentimes the case. Interestingly, you can leave out the first number and it will assume that you wanted 0. So here we could say, I want the first 3, which are GEO. All right, now what if we wanted the last 3? Or what if we wanted to, so before we get the last 3, what if we wanted to start, like let's say the first 3 letters were always just a region identifier and we didn't need those. We wanted to start at the 3rd and go to the end, we could also do that. So see, this will just start after the first 3 and get the rest of the numbers. I mean, the rest of the letters. Okay. All right. Negatives are also accepted. What do you think a negative might do? Well, let's look for a second. So we can start with -3 and go to the end. So anytime you leave one of the numbers out, you're saying go to the end or start from the beginning. So this one here, -3, will give us the last 3 characters in the sequence, or the last 3 items in any sequence when we start talking about other sequences. So this is how we would find out if it was a shapefile. We could write another if-then statement down here, like this, and say if -3 colon nothing, you don't put anything after that, is equal to SHP, we could say this is a shape. You can use that for all sorts of things. We can find out if things are shape files. We can find out if they're text files. And that would be important if we had a script where we wanted to make sure that the user had inputted a text file rather than a file of a different type. So it says that's a shape file. If this said SHX, it's not going to say that that's a shape file. All right, so we can we can loop through sequences, we can get the length of sequences, we can get the index of any sequence. We can get an individual element using the index, and we can also slice a sequence up and get pieces of a sequence. Those are the things that we've talked about up to this point. Okay, and we can do all of those things for any sequence that there is out there. Okay. Now, there are some things that we can do just for some sequences, and we'll start out with strings because that's our topic for the first little while. We'll talk about a few other sequences, but for right now, let's talk about strings. Okay, there are a number of functions that we can do things to strings. Okay, and one of the things that we could do is maybe look them up on the internet. Okay, this is a good good exercise in finding answers. Okay, so one of the things that we can do to strings, there's lots of things here. I'm going to go over some that are more useful than others. It might not seem that this one or this one, the string lowercase or the string uppercase, are all that useful, but they can take a string and convert all of the characters to uppercase or lowercase. Anybody think of a reason why that might be useful?
In case you're importing like locations sometimes, and you're looking for lakes, maybe.
Mm-hmm.
But somewhere you might have pulled from, like have a capital L, the lowercase L's, and you're just looking for lowercase L's.
That's exactly right. So anytime you're looking for a certain value to be inside of a string, you could, if you wanted to, put a few different if-then cases. Well, if they spelled it capital L, A, K, E, or if they spelled it lowercase l, K, A, E, then it's a lake. You'd have to write like 3 or 4 lines of code to do that. Well, if you changed everything as it came in to either upper or lowercase, then you could compare it only to the word lakes, either upper or lowercase, whichever one you decided, and you could instantly tell whether or not that value was a upper or lowercase value. So I'll demonstrate that here. Okay, so right now I have this thing, right, that says your name starts with a G. Well, what if I put a G here and I try to run this? It's going to tell me my name, well, it's not going to tell me anything. It's not going to say it starts with a G at all. It didn't enter this because a little g doesn't equal a big G. They're 2 different characters. I could modify this slightly by doing this, uppercase. That's right here, okay? So this is the function. So now it's going to take whatever value is here, convert it to uppercase, then compare it with this G, and now it will tell me that my name, I'm messing up my my computer programming languages here. Might have to import string. I forget whether it's built in or not. Here's a second. So I'll run that one more time. All right. I'm having a senior moment, I guess. Brain fart. Okay. Oh. It says uppercase, doesn't it? Did I just read it wrong? It says uppercase. Oh, string constants. Okay, so I should be down here in string functions. Sorry about that. So here we go. Instead of saying we don't need this import string, don't need this. I was right the first time. I just had the name of the function wrong. So name should just be dot upper, and then you put the it's a function. So, but it doesn't require that you put the name of the string in there because it's a function on the string itself. Okay. All right. Now this brings up something that we haven't really used too much of yet. Okay. Notice that we had the name of the variable right here, and then we use this weird syntax that we haven't done too much of yet. We said dot upper, and then put the parentheses there, and there's nothing in that. There's nothing in that those parentheses. Okay. Now this is something that's different in some computer programming languages versus other computer programming languages. Things that are more object-oriented will use this sort of notation where the function is actually something that is part of a thing that we're going to call an object. Okay. Now, in this class, we're not going to build our own objects, really, but we're going to utilize a lot of objects. We're going to utilize an object that will allow us to call ArcGIS commands. And this is really one of our first introductions to one of those objects. So this variable has certain properties and values that we've already discussed, but on top of that, because it's truly an object, we can ask it to do certain things to itself. And one of those things is create an uppercase version of itself. So that's what this does. Okay. Name 0.upper will give us a G, and it will capitalize that G. Now, if the G was already capitalized, that's okay. Nothing bad will happen. It'll run without argument. Okay. Still starts with a G. So that's what's so great about it. Whether or not the G is capital or not, we could still get a value that compares favorably. In other words, it returns a true to a capital G. All right, we could do lower. Let's see what we got. Some other functions over here. We can actually do count. Of course, that'll just tell us the number of characters. So that's not really that important because there's another way to do it. In Python, there's not always two ways to do things, but sometimes there is. We try to minimize those things. All right. The next one I want to talk about is split. Okay. Split is very useful. Split will take a sequence. It'll take a string. This doesn't work on sequences. It will take a string and it will chop the string up everywhere where you tell it to chop. So here's my example. I'll go down to the bottom for this one, and I'll say, by the way, I'm going to delete the .s. Before I do this, I'm going to save it as example 2 so I can move on here. All right, so I'm going to say names with an S equals name dot split, and then I'm going to split on spaces. We call this the delimiter. You've ever heard that word before? Here in this help, it's called the separator. So it's going to split it whenever it sees a space. And now I'm going to print names. Print names. Don't really need any of this other stuff now that I have it in the other file. Okay. So I'm going to run that guy. And now I get this crazy thing that says bracket, George in quotes, comma, bracket, or sorry, Thomas in quotes, comma, Raber in quotes. All right. What is this? Well, let's go ahead and ask it for its type. So we're asking names what type it is. What's your data type? We know what its value is. This is its value, okay? But we don't know what it is yet. When I run this, it tells me that George Thomas Raber is its value, but it's of data type list. So this brings us to our next topic, a list. A list is another type of sequence. So we've covered strings. Strings are one type of sequence. The next type of sequence that we're going to cover is a list. Okay. All right. When I say make a list of something, or maybe if I just ask you, what is a list? What would you say up until this point? In general, what's a list? What can a list contain?
Multiple names.
Multiple names, right? Is there really any restriction to what a list can contain? Like I could say, here's a list of items you could get at the grocery store or at Walmart. I could tell you to get a banana, and I could tell you to get a Southern Miss t-shirt, and you could write all that stuff down on the list, right? Well, you could also have a list of all the things you have to do today. You could have a list of things. And that's really that's not really what similarly, I'll say it like this. Similarly, a Python list can really contain anything, any values that you want it to have. So lists can be a list of strings, or it can be a list of numbers, or it can be a list of, it could be a list of lists, in fact. It could be a list of floating point numbers. It can be a list of integers. It can be a list of functions even. And that would be a more complex use for a list. But really, there's not any restriction on the elements that a list can contain, as long as those elements within a list are also valid data types. And another crazy thing about lists is that they can be mixed. A list can contain numbers and it can contain letters. Okay. Oftentimes we deal with lists, you'll see as the course develops, where all the elements are of the same type. In this case, they're all, what are the elements in this list? Yes, they're my names, but what data type are they? We can tell by the notation. Yes, so George, Thomas, and Raber are all strings. In fact, even if we did something like this, where we wrote George, Thomas, Raber, and we wrote, let's say we wrote 40. Okay. So now we run this. George, Thomas, Raber, and 40 are still all strings. How can I tell they're all strings? I can see the quotes around them. Yeah, got some air quotes going. Okay. they're all strings because they were all strings before, and when we split them, they're still strings. Okay? But we can make our own lists. So I'm gonna make another list here. Well, I'll go down underneath and say, I could just go ages. Ages equals 34, 45, 23, 46, 21, 18, 33, and so on. Okay. So that's another list. Now I'm going to print ages and run this again. So now you can see that it's basically just reformatted it a little bit, put spaces in between. I could have put the spaces in there before. That's not really important. We can see these are the individual elements in my list, these values. 34, 45, 23, 47, 21, 18. Those are the individual elements. I can do things like I can get the values out of there. So I could get the third age. I'll run this again, and it's going to give me, should have asked beforehand, 46. I said the third age. Is it really the third one? It's really the fourth one. 0, 1, 2, 3. So that's what it says, 46. Okay? So all those things that I talked about earlier, we can do with lists because they are also sequences. The only thing we can't do is convert them to uppercase, lowercase, and split them like I talked about before. We can't split ages. Can't split it on spaces. It's going to give me an error. It's going to say split isn't defined for a list. A list object has no attribute split. We can't do that. We can't do uppercase. Even if, I'll show you here, can't do it. Even if we're talking about this, names, okay, that's not gonna work. It's because names is a list now, okay? I could do something, more fancy. I could say for names, I'll say n in names, and then I could say print n dot upper, and then run this. Actually, before I run it, let's see if y'all could guess what this output's going to be for this little line. And what is n, first of all? Well, the first time through, n will be the first item. The second time through, n will be what? Yep, and the third time through, it'll be the third item, okay? Now, what are the items in names? Where did the names get created? Right here, right? So what are the items in that? They are characters. Well, no, the items in names are strings, which the items in each one are characters. So, okay, let's look at this. Right here on the first line of code, name is set equal to this. I'm gonna go ahead and delete the 40 because it might be confusing, okay? George Thomas Raber with spaces. Okay, review, what does this line do?
It splits up the string into different strings by spaces. Right,
it splits them up into different strings by spaces and stores them in a new variable. What's the new variable called? It is a list, and it's called names, exactly. Okay, and then I print them right here, and I ask for their type. Okay, just I create another list. Finally, right here, I've tried to run this names.uppercase and it died, so I need to get rid of this line. Okay. It would have died even if I said upper, although I did call it uppercase. All right, so now when I say for n in names, what's the for statement doing? It's gonna loop through what?
Loop through the names and print the number of uppercase names. So the number 3.
Yeah, I think you're on the right track. It's you have a little bit of confusion about what the upper does, but it's exactly right. It's going to print my names in uppercases. It's going to yell at you. My name. That's what uppercase usually means, right? I'm yelling, George Thomas Raber. Yay! Just kidding. So then that's what it did. So it just made those. It made that loop, and it capitalized each one as it printed it. All right. So that's what the for statement does. It loops through each element in any sequence. Now we could have done something, we could have nested these like out here. I'm going to do this as a separate one. We can nest these loops. I'm going to comment this out though, because it'll get confusing. All right, so now when we go through this loop, we're saying for n in names. In other words, what we're doing is the first time through we're going to get George, the second time through we're going to get Thomas, and the third time through we're going to get Raber. Then we're going to go inside this loop. The first time through, n is going to be George, and so it's going to print out each letter of George. Then it's going to go and print out each letter in Thomas, and finally each letter in Raber. So we can nest loops. So we'll run this again, and we can get all the letters of my name printed out. Okay, I mean, nothing that exciting, but we're going to need this. Okay, when we do the lab today, we're going to make it a little more geographic, applying the same principles. Okay. All right, there's a few more skills that we need to learn though before we get there. All right. I'm going to clean this up a bit. I'm going to go ahead and save this one more time, and then I'm going to say File, Save As, Example 3. And I'm going to paste my new list here, my list that just contains numbers. Okay, so now we're going to learn some skills that have to do with things that we can do with sequences, because oftentimes we're going to deal with sequences, but what we really want to do is find out about that sequence, or we want to take some of the elements of a sequence, and there are a few different types of functions that we can utilize and that we can create that will allow us to do those sorts of things. So sometimes we want to do what we call reduce a list of values and summarize, reduce and summarize a list of values. For example, we might be concerned with the average age, and that's what we're going to calculate here. If these ages might represent a bunch of people, or they might represent a bunch of streets, and we're trying to figure out the average age. But as geographers, there are a number of times where it's important to calculate the average of some list, okay? All right, what's the formula for calculating the average of a list of values.
Yeah, to add them, then divide by the number of values.
Exactly. All right. So if I went like this for age in ages, that's kind of the same thing we've been doing, right? This is just going to print out all the ages. What if I wanted to create a running total? We've done that. We did that a little bit in the while statements. How might I do that? I wanted to get the total number of adding all of the elements up. How might I do that? Anybody have any suggestions? There is a general sum function, but we're going to talk about that later. We're going to calculate it by hand. First, we're going to talk about the sum function until we talk about numbers. So by hand, how might we do this? In fact, it means only a few lines of code. 45, right? Okay, but as part of this loop, remember when we
break up into the list and then
we demonstrated this a little bit when I asked you on, was it just last week's homework where each time through the loop, we had to keep a running total?
Plus equal.
Yeah, exactly. So plus equals, we'll keep a running total. So if I say like total equals 0, I start out at 0. Or maybe I could just call it sum. Oops, looks like that's a reserved word. I'm gonna call it total. And then I could say total plus equals age. Then when I'm done, I unindent in order to get out of the loop and print the total. So now I can run this, and I'm going to print all the ages, but at the bottom, what does this value represent?
The total of all the numbers.
Exactly. All right. Now, how could I change this so that it was actually the average? Divide by n. What's a quick way of getting n? We have demonstrated it. So, see how that will work? So now I'll be able to run this, and the average is 31. Okay, now I'm not sure if that is the actual average. I won't know unless I float one of these values so that it will return a floating point number. There we go. So that would be the precise value. 31 is rounded. So in Python, you have to explicitly change the type of one of the two numbers if they're both integers. Otherwise, it will return an integer value. Okay. All right. So that's a quick way to calculate the average. We could even write something like the average value, the average age is. There we go. Well, there are a few. So putting a comma here allows me to mix. This is a string, and these are numbers. So it allows me to kind of mix the two data types. I could also have gone plus, but then I would have had to convert it into a string. Just showing you two options here. That? Okay. I think this one is a little neater. Put this comma in this case. Okay, for the homework, we actually ask you to calculate, in addition to, where'd it go? Yeah, they're both over there. This should be on this side. No, yeah. Okay. So on the homework, we actually ask you to calculate standard deviation in addition to calculating the average. Anybody know how to calculate standard deviation? You may not. Exactly. All right. It's, well, not exactly, but it's close. Right. You have to then take the square root of the square differences. All right. So how do we get the differences from the mean?
From the item, from the number.
From each item, right?
Yeah, square.
Right. So we actually have to, I'm going to go ahead and save as. What we actually have to do is go through the loop how many times? At least twice. I think twice will be sufficient. So what I'm going to do here is say mean is equal to, so this, you guys want to argue that that equals the average now, right? That's the, this is equal to the mean. So instead of printing it right now, I'm taking the average value. See what I'm saying? Okay. So now we're going to go through the list again for age and ages. Okay. So what do I need to do? I need to find the difference between each element and the mean. So what would my next line of code look like if I want to find the difference? And I could call it the difference. Diff. Oops. Creating a variable. I'm setting it equal to what? In order to get the difference between each element and the mean. So
this, like we've done here, each number and subtract each number from the mean.
Okay, yes, I have to subtract each number from the mean. So what's the rest of this line look like? Diff is equal to the number. So we just need to figure out what variable represents the number minus the mean. So we just need to figure out what variable represents the mean. So what variable represents the number?
You have to take the highest and the lowest and then divide them by 2. Right? That's the median.
Yeah, that's the median. So in this case,
We've got to print the list of numbers.
Well, I don't really need to print anything. In fact, I can delete that if I want to. I'm wondering if y'all are struggling with the math.
I'm confused what you're trying to ask us.
Okay, so I'll put a comment in
I know
here.
what you have to do next, you have to calculate where each number is set. You subtract the mean from that number first to find the difference between the mean and that number to see how far it is from the mean. But not kind of,
So something like this, right?
yeah,
Okay. So, but number isn't a variable at this point.
right.
What variable represents the number that we're trying to subtract?
Ages.
Ages has all of the numbers. This is a loop, and we only want to do one number at a time. So ages is close.
age 0, colon.
Definitely what we need to do is say age 0 minus the mean, age 1 minus the mean, age 2 minus the mean, age 3 minus the mean, and so on, right? But in a loop, ages, so this is an important concept. We're getting there. Ages, we need ages 0, ages 1, ages 2. You all need to understand that in doing this loop, the first time through the loop, age is equal to ages 0. The second time through the loop, ages is equal to age 1. The third time through the loop, it's equal to ages, and so on. So if I type age here, the first time through the loop, this is going to be equal to 34. I'm going to subtract that from the mean and store it in a variable called diff. The second time through the loop, age is going to be equal to 45. I'm going to subtract it from the mean and store it in diff. See what I'm saying? Here, I'll print this. So see, the first time through the loop, second time through the loop, third time through the loop. So I looped through the variables twice. Why did I create this loop? What is this loop giving me at the end? Yeah, it gives me my mean, but before that, what does it give me? The total. So I needed to go through every value to get a total. And what is this loop now doing for me? Right now, it's not doing much. This one right here.
That's giving me now the differences. 8 minus 1.
Right, it's giving me the difference of each. These are the difference between, so 34 minus the mean is 2.57 and so on. Okay.
So on how
yes, well, basically we need the average of those values. That's what the standard deviation is, but not exactly. Okay? Technically, it's the squared. So I'll help you out here because
Technically, what you're doing is you're getting rid of the sign. You put one square and then square.
I'm going to call this SQ diff is equal to diff times. And again, if you don't know how to calculate standard deviation, that's not what this class is about. I'm telling you that this is what you need to do for calculating the standard deviation. So what this is doing is getting the absolute, well, not the absolute difference, the difference. Then this is squaring that difference. And then we actually need to find the total of that value. So we could do something like this, create a new variable called diff total. So that's going to be the total difference. And here what if we want diff total to be a running total of the square differences? We did, oh, sorry, that's what I meant to do. Okay, and this line, we basically want to do the same thing, but instead, we want to be doing something a little different. So what are we doing here? Diff total plus equals what? We want the total square differences. Yeah, square diff. So now the diff total will be the total square differences, and we want to get the mean of those values. So we say something like, let's call it variance. We're going to use one more math term here. The variance with an E or an A? Variance equals float. They're all going to be floats already. So diff total divided by what? Oh, this is part of the math. It's again the length of the ages. Okay. So I'm going to print that variance. I'm going to run that. And I get a value 109.387755.102. Okay, that's the variance. And again, if you don't know this, I'll just tell you, but how do you get the square root from the variance? Anybody remember from math? Square root, exactly. All right, so we remember that. We have to import math to do that part. And then just say here, stdev is equal to sqrt, or sorry, math.sqrt of stdev. And now we can print the stdev. So we had to go through the loop twice, but we calculated standard deviation. Oh, variance. So I messed up. You're feeding it the variance, you're getting out the standard deviation. All right. What units are standard deviation? Is the standard deviation in, by the way? Anybody remember? Yes, whatever your units are. So we could say, I stopped printing the mean here. Well, I could just say mean, comma, stdev. I'm going to run it again. So this is the mean. This first number is the mean. The second number is the standard deviation. So what that means is the average age is 31.428, and the standard deviation is 10.458. And you know, this class isn't necessarily about teaching math concepts, but basically it's telling you the average distance away. So if I had another group of people and I looked at their age, it might be I might have a similar mean, but a higher standard deviation. And I would say that that group is less homogeneous. Okay, their ages are more spread apart than the one with the lower standard deviation.
The example I like to use is like a kindergarten class. Survey the ages of kids in that class, the average is going to be 5, and it's going to be really low standard deviation because all of them are going to be 4 or 5 or 6.
Yeah, exactly.
As opposed to a college class where you could have someone who's 18 in the class and someone who's 35.
Right. Or even if you went into elementary schools usually go from K through 6. So right in the middle of that is 3rd grade. So if you went into a 3rd grade class, the standard deviation for ages would be less than 1 because everybody would be right around 7 or 8, I think. But if you went in and you did the same thing for the entire school and you calculated the standard deviation might be 7 or 8 because there's probably about equal numbers in all the classes. However, the standard deviation, so the mean would be 7 or 8, but the standard deviation would be not less than 1 anymore. It'd probably be closer to 3 or 4 because of the kindergartners and the upper people above that. Actually, it'd probably be a little bit over 2 because it's the average distance from the mean. Okay, so we just calculated mean and standard deviation, and the reason that we did that was to practice these methods for taking a list and condensing them. Okay. Now there are multiple different ways to condense lists. We could have had a list of strings, and we could have found out what the average length of all the lists of strings contained. We could, instead of calculating the mean or the standard deviation, we could have just calculated the total. We could have calculated some other summary statistic. Mean and standard deviation are definitely the most common, but we could you pointed out on the coach, you pointed out the median. We could have calculated the median. It would have been a little bit harder, and we haven't really talked about this, but there's a Python method for sorting a list. And so you could sort a list, find its length, and then find the center value and have it return the median. Okay, so that's possible. In fact, let me just show you that you could say ages dot sort. I think that's all you need. Print ages. I'm gonna run this again.